Yeah, thank you very much. So, welcome everybody. Let's talk about the pillars of domain-driven design. First of all, I'm super stoked that so many people showed up for this topic. That means domain-driven design is getting more and more and more traction, and I love that because I have a very unhealthy relationship with building business software. I started the German DDD community in 2012 or 2013, and I do multiple DDD barbecues in Germany once a year, and I even have my own conference in Berlin in October, so you have one more year to wait for the greatest conference about DDD, in Germany at least. So the pillars of domain-driven design, I'll give them to you just from the beginning, so whoever wants to leave afterwards, here they are. And I'm totally aware I say pillars of DDD and then I show you rows instead of columns, but that's just how words are written. So the pillars of domain-driven design, the things that it's totally based upon is communication, empathy, and the ability to learn. Software products almost never fail because programmers are bad at programming. It's not because people don't know how to use a framework that a project goes haywire. It's because people don't communicate their needs correctly, or people don't ask the right questions. It's because communication fails between business people and the programmers. But even if we're able to communicate well, even if we understand how to do communication, empathy or compassion, like a feeling for the needs of others, what they really want, what they really need, is an ability you can learn, and you should if you want to build good products. Because people always come to me and they tell me what they want, but they don't know what they want. We need to figure that out together. We need to talk about their needs, about their pains, and in this process of modeling and discussing, and even while we code, we get a lot of feedback from all directions that pushes back into the whole design process. So the ability to learn, not only about technology, not only about architecture, but also about psychology and about the way of modeling together and talking with business people, and even about the domain itself. Super important. I would stress the last part most. As software developers, we shouldn't be interested in the first point in technology. We should be interested in the business that we're actually solving problems for. So, software becomes what developers understand, not what business people mean. So no matter how good they explain their needs or what they want, or no matter how good we model it, what the developers understand is what becomes software in the end. So we better make sure they understand it correctly. So how do we do that? The first step is to structure your organization aligned to your business needs instead of to technical needs. Who here works in a department for database or UI or any technical concern? It's just a few hands, still a few too much, but great that most of you don't. So in ancient history times, some of you might be old enough to actually have been there, companies were structured and they had a DB guy and a DB girl, and they had the people that cared for the domain, they had people that cared for the UI or for different parts of the infrastructure. But that's not the kind of problem we're actually solving for the business. What we're doing is we're solving business problems, so we should structure our teams vertically aligned with the business needs. Melvin Conway said once, companies which design systems are constrained to produce designs that are copies of the communication structures of these organizations. So if that guy there and I, if we hate each other, how should our software components talk, right? If we're in a distributed company, if everybody's working from God knows where, we are not prone to build a system with a centralized server and clients that work with that. But if we have a company that has like a boss and an underboss and then the soldiers underneath, it's very unlikely that we build a nice distributed system based on distributed trust and stuff like that. So from a business perspective, the needs of the business are what drives the design of the software as well as the design of the organization. Software development is always a socio-technical thing, where both things come together. So that's where domain-driven design introduces the concept of bounded context. A bounded context is something in the business that is just a subset of the whole domain that makes sense in itself. It's linguistically separated from the rest, from the other bounded contexts. For example, if we try to build an online shop, let's say Beamazon, good competition for Amazon, and we try to start that company, we might come up with these bounded contexts after a short modeling session. We say whatever happens in shopping does not affect payment at all. Or maybe there's just a slight connection there. Whenever someone bought something, they have to pay, of course. But no matter how we change our shopping business and the code and the software used for that, payment doesn't change. The payment team doesn't need to adjust the software just because we changed something in the warehouse. So why would we build a distributed team where some people work in database and some people work in the UI? We want to have a team that works on shopping and that cares for the persistence layer, the business, the messaging, and the UI. And the same goes for all the other bounded contexts. Now the thing is, when we find out we have all these different contexts, and how to derive good context boundaries is an art in itself, and we're going to get through that, to that. So if we have all these different contexts, they have different levels of complexity. So if we design our software and our teams aligned to the business needs, we can actually model the complexity of each context in itself and have a different way of approaching problems on there. So this is a Kinevin framework about complexity theory. If you have an obvious problem, let's say I'm a German and I see the beer is empty. What do? I sense it's, oh my God, it's empty. What do I do now? I'm kind of desperate. So I categorize it, lethal problem. This needs to be dealt with right now. And the response, I can delegate. Because it's an obvious problem and there's an obvious solution. In obvious complexity, what you do is you use best practices. So whenever you have best practices in design, in building, in coding, or in any other methodology, in an obvious domain, you can use best practices. Just take them out of your head, delegate, and do it. In complicated scenarios, in settings where you need expertise to actually analyze, you need to study, or you need a team with years of experience, you need to do something else. You can't just sense and then categorize and respond. Let's say my car breaks down in the middle of the Autobahn. That's a bad thing because I don't know anything about cars. So what do I do now? I get an expert. The expert senses a problem, says, oh yeah, this is clicking and this is not humming anymore, or whatever. And then they analyze the problem and they find a good solution. Not a best practice, but a good practice. So in complicated domains, there is not a single best practice you can come up with every time. But there is a variety of practices, and if you have the knowledge and the mastery, you can choose one of those or adapt it to fit your needs. And then there are complex scenarios. This is where it becomes really interesting. A complex scenario is not complex because, oh my God, there's so much code. That's complicated. A complex scenario is when complex systems interact with each other, and it's impossible to derive the best answer or even a good answer from the start. Let's say the whole fiscal system in Europe, which is a simple problem. So everybody has an idea of how to solve this, right? If we would only do this one thing. Well, I guarantee you, no matter how smart you are, no matter how many years you studied and how many experience you have, if you change anything, the whole system will change in unforeseen ways. Because every actor responds in their own way, and you have chaotic interactions. It's so complicated, it's so complex, you cannot foresee the consequences. So what you can do is experiment. What we want to do in complex situations is we want to do small controlled experiments in parallel if possible, so that we can actually derive knowledge. And what we do is we sense a problem and then we probe it. Come up with a scientific method, have some hypotheses and think, oh, if we do this, this might happen, right? So let's experiment, but also have a different idea and experiment with that at the same time. That's where Agile comes into play. You can have lots of iterations, but you should use those iterations to gain knowledge parallel if possible, and then you can respond. And then there's chaotic environments. Chaotic environments is when they are so unconstrained that no rule is applied anymore. It's a place where you usually don't want to be, but sometimes it can also be a place where innovation grows, because if you don't have anything you can cling on, if you don't have any experiment you can do, if you're really desperate, now you get to be really innovative. So in chaos, you act first. You just do anything and see what happens, and then you can form another response. And if that doesn't work, after chaos, just leave. It's better. So we need to find boundaries that enable the core domain, that enable the business to optimize a core domain. What's a core domain? What do you think is core domain in our business here? Payment, oh, payment, great. Shopping, yeah. Shopping sounds more like it. If we build an online shop and payment would be our core domain, we won't be building an online shop, we will be building PayPal, and we just sell stuff on the side. So shopping might be actually our core domain, which it was for Amazon, I think, in the beginning. Now they just do cloud services and selling stuff as a hobby of them. But we start with shopping as a core domain. So that's where we want to put all our energy. That's where the smartest people go. That's where the money goes. That's where we model the most. And then we have supporting domains like the warehouse system. Core domains means this is what makes us different from the competition. Supporting domain means we still have to build it ourselves, we have to model it ourselves. But it doesn't have to be as specific, as detailed, as great, because it's specific to our business, nobody else can do it for us. but we can build it in any way and replace it later if we need to refine it. The real core of our business, the thing that has to work, is shopping. And then we have generic domains, payment, for example. Generic means you can build it for yourself, but it's such a generic problem, others might have the same, you can just buy a solution off the shelf. So you can just get PayPal in and use PayPal as a payment service. But now you have a relationship between these different domains. We want to focus on the core, that's where all the effort should go into, because that's our competitive advantage. And therefore, core domain is upstream to the warehouse domain, which is supporting. Upstream, downstream is a relationship, so that means if they negotiate any change or anything that goes between both contexts, the core domain should have the upper hand. That's pretty obvious if you think about it. So if we say we want to drive our core domain further, we have a new experiment, we want to see if the market reacts positively. Warehouse should adapt so it actually works. If the warehouse people say, look, we're going to change the message framework, now core domain, you have to change stuff. The core people are like, no, 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 this doesn't fit our schedule. This is not what we do at the moment. So knowing that your organization is designed around the needs of the business first and your core domain gets the most important focus, not the only important, but the most important focus. So it's actually upstream, means you have this map transparent in your business and the warehouse people won't be frustrated. This is about the empathy part of the whole modeling thing. If I'm frustrated because I want the interface to change, but there's another team that's always fighting back and I'm like, why do they always get what they want? Like, if I don't understand the needs of my business, I will be frustrated. But if I understand, oh, we're supporting context, that makes a lot of sense. So let's find a schedule, how to model with them. Let's find a way how to make it work. Sometimes it works well when you just have someone who can do the communication in between. Sometimes you have to protect yourself. So if the warehouse is like, it's a team that has been there for 20 years, and now these new hipsters come with their shopping context, and they do all the great modern software development techniques. And whenever we want to talk to them, they don't even take us serious. So we need to protect ourselves. That's where we can put in an anti-corruption layer. And I draw this on the bounded context map because this is something I want to make transparent in the company I'm working in. When we are in a context where there are two teams that have this kind of relationship, it needs to be transparent. Only if things are transparent, we can actually do something about it. So either protect ourselves by actually building an anti-corruption layer, or work on our communication skills to get to a better emotional safety between both teams. Well, and then we have something like pairwise relationships, which is also something you need to make transparent. So delivery and shopping only succeed together or fail together. If shopping does anything they want, but it doesn't get delivered, there's no point. So they have a pairwise relationship. That doesn't mean that delivery has to be core domain as well. It could also mean it's just a supporting domain. But it means whenever something changes, they need to make sure they still work together, more than with the warehouse. So how do we find these context boundaries? Well, context boundaries are guided by a lot of different factors. Like it's the vision from the domain. It can change. Now it's shopping cart, or now it's shopping, the way we advertise. In a few years, once that's kind of settled, we might want to optimize warehouses because it's cheaper if you have robots that find stuff and distribute warehousing. That's where we can make more money. Core domain can shift to another domain later in the game. But also from product on the market, expert location, bottlenecks you have in the development process, data cohesion, things that change together belong together usually. So if you realize whenever we change something in context A, we have to touch context B, that's a good smell. It's like, oh, maybe this is one new bounded context, or maybe we draw the lines wrong. So a bounded context map is nothing that is static. You build it once, but then you evolve it. It evolves all the time, driven by technology and by business from both sides. So that's basically one team per bounded context. You have a team that's consisting not only of developers, it's consisting of developers and business people that talk together in the same language, of course. And then you have another team in another bounded context, and there is a slim interface that is social on one hand, so there are people that have to talk to each other when they model the interface, and there's a technological component to that. So it's always socio-technical. So what do people in those teams do? You have business people that talk to programmers, and programmers look into the code. And what usually happens when you do that? There's a lot of brain power involved because business people tell you, oh, after 2 years of taking 30 days holidays per year, if you're in that salary group, you have to blah, 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 business rule X, Y, Z. In my code, it says SQL, go to Hibernate, blah, 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 Docker this, for I2 loop. That's not the same language. So I have to transpile in my head the whole time. I have to think, oh, this was business people say, that's it, this loop, that's this method. And we all know clean code, and because you're in this talk, maybe you even know domain-driven design. So, of course, we can rename, refactor stuff and make it more explicit, but still, the code doesn't speak the same language. There's a lot of technical stuff and fluff around. There is no classes in real life. I mean, there are in school, but in our shopping cart, there's no class, but there's new class something, something in my code. I don't want that. I want to have the mapping be as slim as possible without relying on a framework that is another technical dependency again, right? So the secret sauce here is ubiquitous language. It's a fun word because domain-driven design is all about communication and the ease of understanding, and it uses words like ubiquitous language. It's great. So I brought you a ubiquitous language for my living room domain. That looks like Java. Wonderful. Thank you for that comment. So who has written code like that? Who's lying? OK. We see something. We see a pattern here. There is useful stuff, domain terms, and they are trailed by kind of like a pattern language. So we have these weasel words that have no meaning. It's like from a Shakespeare quote, the weasel sucks eggs and leaves an empty, meaningless shell. We have weasel words like the Hungarian notation. If you have a word, if you have a variable name that says double something something or int something something, it doesn't add meaning to understand what it's actually doing. You have an IDE today. You can just hover over it if you want to see the type. You can have a code lens, no problem. But adding that to the variable name gives it a lot of focus that's not necessary from a domain-driven design point of view. And the same goes for simplicity or for importance. Like you have a basic customer and you have an advanced customer. Basic for you maybe, but I'm not so smart. So what does it mean? It doesn't add meaning, and it's ambiguous at best. And you also have even the pattern languages, Gang of Four or domain-driven design. You have like a customer repository. Yeah, what you have is a list of customers. Repository is just the pattern. If you change the pattern you're using, if you have a decorator or whatever, there's like, we don't have to read all those words. It's just the start of a very long list of bad words to put in code because they're technical descriptions and not business terms. So if we use those things, if we stop using those things, what remains is business text. Then you can actually understand what's happening here. If I change my pattern from a repository to a data access layer or to whatever later on, why should my domain code change? I'm still just receiving the list of customers, so it doesn't matter what the pattern is inside, right? Sure. So let's get rid of all the weasel words. Good language. Oh, wait, it's not. We have a problem now. The multi-but supporter just became a multi-but. And that is definitely wrong. And I think there's a code of conduct violation here as well. But the problem is the word supporter is a technical pattern as well as a domain term. So, oh no, what do we do now? We have a mix of languages. If we have the rule of saying there shouldn't be any weasel words in code, then we know that the word supporter is not the technical supporter pattern. It has to be a domain term. But we need to make this rule explicit and enforce it. So instead, we should talk to business people about those terms and put them in our code, because that's what business people actually think if your business is living in a living room. But for simplicity's sake, right? So I brought an example. Let's code together. This is very well-written code. I spent half an evening of doing that. Can we optimize it? I mean, that's a loaded question. The answer is yes, but how can we optimize it? Yes, so we have redundant information. It says by year of birth and then the parameter year of birth. So we should get rid of that. We should just say get customer by and then the parameter. Can we do more?
Name it to just customers.
Yes, get rid of repository, what we just discovered. It says customer repository. From the inside, that's true. But when I read the usage of this class, customer repository.get, that's not how people speak. It's customers dot get by year of birth. Can we optimize more? Stay with the get name. Customer.get year of birth. Then you'll get the year of birth instead of the customer. Yes. Okay, so get you. So we differ a lot in our opinion about getters and setters. I hate getters and setters from the deepest heart of my, bottom of my heart. Getter is meaningless to me. I'm not criticizing, but I say it's meaningless to me because everything is getting something. When I call a function, I get the result. When I ask the memory, I get the result. When I ask the database, I get the result. That's a given. Whenever you have a return type, you get something. So it doesn't add meaning from the business perspective. And that's not how people talk. I don't go into the room and say like, hey, audience members, get by year of birth. Like, I've never said that before. What I do say is, hey, I want to have the audience members born in year of birth. Not find. I'm not finding you. I want to have the list of customers. Let me show you what I do. I would call it customers and give it a function born in year. Because the year of birth has been a date time. So the 2nd of January and the 3rd of January is a different thing? No, it's not. Why don't we use an int? Because an int is not a domain term. I forbid in my domain any primitive data type. There is no string in my domain unless I'm in guitar production. So in my domain, there's a name or an email address. A name cannot be null or empty or have one sign. Depending on your culture, a name has to have name and family name or a middle initial or stuff like that. So make it explicit, make it a type. It can be a string internally, no problem, but it should be its own type, so it's expressive. So if you want to have a name, you'll get a name. The great thing is, when you have this value type and you get a name, you already know it's a legal name. You can never construct an illegal name. The constructor should forbid null, empty, and all those things. So you don't have to check on null or whatever parameters or frame of values in any other function. You always know my types are legal when they're constructed. That's beautiful and very expressive. And my height is an int, and my age is an int. So if I get a tuple, I can mix them up, right? Or I can refactor a method and forget a call site. All these things can happen. If it's type-safe, if you have a type-safe language, that gets compiler errors immediately, and you know, oh, I'm messing up something here. That's great. So I want to write my methods as they are read while used, not as they are written from the inside while I think about what I'm doing technically. That's complicated, right? Let me show you what I mean. Instead of saying customer repo is repo get by year of birth, new datetime, something, something, which is how most programmers read their code, I would say all customers born in year of 1968. That's a very neat trick in domain-driven design by Eric Evans' book, that says model out loud. No matter how obvious the function seems to you, once you say it out loud and it seems awkward, you know it's not real language. Business people don't say repo get by year of birth or customer repository get by year of birth. They say all customers born in the year of 1968. You can read that, it makes sense, it's perfect English. So now you have your list of people turning 50 this year. I didn't check the math, but should be fine. So how do we build a value type like that, like year? This is a small C# example. Who here codes C#? Who codes Java? Wow, majority. I'm sorry. So there was a question over there.
Yes, I have a question to the previous
yes, please.
slide. Actually, the one behind. Yes, exactly. What about the return time type here, enumerable?
That's a very good point. What about the return type, IEnumerable customer? That's a trade-off I do. So there is no perfect design. Right? The perfect language would be if I could just write prose, just a text, and it understands me. That would be perfect. So we always have stuff that is programmer languagey, and I'm trying to get rid of as much as possible. For IEnumerable, it's a defined type that says this is just an unstructured list. It's just an unsorted list of things, an enumeration. That concept translates to real world. Like if I get a list of your names and I don't care about the order, that's what I get. But if you say, I want to make it more specific and more explicit, do that. Just build your own type that says list of customers, that's fine. So whatever suits your needs to be more expressive in code. Because I use the var return type, as you can see in the usage, you don't see that IEnumerable in code usage, so I don't care about it. When it becomes too much of a hassle to read, build your own type, sure. So, value types, that's like the low-hanging fruit of DDD. Whatever you can start with, some things require that your whole business is on board, some things require education of the architecture team, but every programmer can start with value types tomorrow, if you're not doing it already. A value type here, I just have a struct of a year, it has internally just an int, but I check in the constructor if it's in a legal time frame. Anything between 1900 and 2200 goes in our domain, so if that's not fulfilled, I throw a domain exception, otherwise I put the field internally. But then I have a private constructor, so no one can say new year, because there is no new year. Well, once a year, that's a big party, it's new year, but there is no new keyword in the real domain language. So I want to say year of, and then enter a number, so I can have a very explicit constructor. So, this is for all the Germans in the house now. Woohoo. Any Germans here? Yes, great. So enjoy the code. The rest of you, this is how code looks when you do domain-driven design in a German domain. And if you work in Latvia or in Lithuania or any other country that has a non-native English-speaking population, a lot of your domains will be non-English. So if you translate every term into English to build your domain code, all the programmers will be like, sure, we always do this in English. But the business people don't. And there are so many terms that have a very specific meaning, not just a literal meaning, but there is a hidden meaning inside of the domain rules. And everyone understands, if you say these words, what it means in the domain. If you translate them to English literally, they don't mean the same thing anymore. So you need to find a glossary. And how many of you write code, read code, and look up the glossary all the time? Good, there's no hand up, that's good. Nobody's lying today. So yeah, this is, you don't have to understand, this is just all German marbly-garble. It's function names and enumerations and objects and constructors in domain terms.
What about
yes, please.
who don't speak
Yeah, good question. So, but what do we do about programmers that don't speak German? And this is where trade-offs come in. You know, as a consultant, I always say it depends, but on what? So it depends on strategical mapping, how you actually organize your domain. If you say shopping is our core domain and we shop only in Latvia and our domain has very specific terms, so you know, your own language would be the great choice for that, but half of your team is English speaking. If the other half, I don't know how your language is called, Latvian speaking population, if those programmers actually understand the domain and the others are really good at cloud services, Docker and stuff like that, let them build infrastructure and let them build the domain rules. Perfect. Then you even have an orthogonal separation between infrastructure and domain. That's perfect, that's what you want. If you have an international cast, if your programmers are from all over the world, then you would lose a lot of programmers by doing everything in the domain language of your customer, and you will gain a lot if you translate it to English. So there's no clear rule. It's not like, do it always like this. But have in your mind that it's possible, because the default is, even if everybody's speaking German, and it's a German domain, people are like, now translate into English. Why? There's no need for that. You gain a lot by writing actual domain code in the business language itself. You even have a nice code smell now. When you see English and German in one method mixed, or your own language and German, you know what I mean. When you see two different languages in one method, you know, oh, I'm mixing technology and business here, as I do in the last line, where I say, berechne Grunddaten, blah, 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 should be Tage 20. Because should be is my testing framework. That's something we bought from the outside, and I didn't want to build my own test framework around that just to hide it, because it doesn't matter that much. But it's a code smell, and I can see it. So,
Chinese, for example.
yeah. So now we get into the interesting bits that we can discuss that later, because I really want to try that. What if it's Chinese? I have no clue how Chinese letters look in code. I don't know. I've never been there, so maybe that's going to be an interesting coding challenge. So, ubiquitous language per bounded context, that's very important. You have this ubiquitous language, you have these value types and your entities and your function names, and everything is very expressive and there is no repository anymore, it's just domain language. But the same term doesn't mean the same thing in different bounded contexts. Let's say, for example, we have a customer, our shopping cart customer, and our payment customer, and delivery customer, and a warehouse customer. Like it's one big customer class that we use everywhere, right? No, that would be really bad design. If warehouse decides to change anything, now we have to test shopping cart and payment just to see if it didn't break. That's not what we want. So the word customer is specific to each bounded context, and then we figure out they change in different paces. So in shopping, we change all the time because it's core domain, we experiment a lot, and we realize, yeah, the customer has more behavior, great, but in payment, we don't have a customer. In payment, you have creditors and debitors. Oh yeah, you build a customer first, but after a few weeks, you realize your domain model was wrong, and now you refine it. Now you have creditor and debitor, two different classes, and they don't even interact. They have the same natural person as a reference, sure, but it's two different functional classes with different behavior, and you can change them in their own pace. In delivery, there isn't even a customer class at all. There's just a delivery address or a shipping address. So having your specific domain language per bounded context makes it easy to change code and to have your code always have specific meaning when you read it because it's context dependent. In C# we use namespaces for that. You could also use your own repo or whatever suits your needs. Just make it sure that the programming language or the environment you're using is supporting the idea of, oh, we are in this context now, so these words have meaning. And there shouldn't be technical the ability to mix that up. And then, yay, we had strategic domain-driven design. We now have teams consisting of business people and technical people that work together in bounded context that speak a very specific language that they focus on, and the interaction between two contexts gets governed by both teams. So if I say shopping says order shopping cart, and then warehouse says, oh, order shopping cart comes in, this one message needs to be understood by both. So either they pair up and say, look, we have one message that we designed together, or if we do the anti-corruption layer thing, they throw at us whatever they think they want to throw at us, and in the anti-corruption layer, we translate it to whatever we understand. But both contexts are pure, and they don't need to understand the internals of the respective others. So that's what Eric Evans was getting at with domain-driven design. It was his book, Tackling Complexity in the Heart of Software. And complexity is not in the whole software distributed the same. We saw the Kinevin framework already, so we know shopping is a very complex scenario, probably, while payment is just generic thing. It's simple from our perspective. You owe us, you pay us, fine, that's it. So with all the strategical planning and the team division, like these are things programmers can't really influence that much. There's also the other part of the DDD book, and Eric says he has written the book in the wrong order. The first 7 or 8 chapters are about tactical patterns, and the later chapters are about the whole important strategic stuff. And nowadays he would write the book in the other order or just make it 2 books, because many programmers focus on these things. And while they are really important tools, this is not what domain-driven design is all about. So if you are in 2003, you do Java and SQL is your database backend, these are perfect patterns to get more domain-driven. But ever since, we had a lot of development in functional programming, in event sourcing, in message streaming, and all those things. So my takeaway from this is whatever pattern you can find that makes your language more expressive and that enables you to orthogonalize business code from infrastructure code is the right pattern. We've seen value objects, which is perfect to get rid of any kind of primitive data types. There is no primitive data type allowed in your domain code. In your infrastructure code, go wild, use all the ints you can get, but in my domain code, there is no int. I want to see real value types. Same goes for entities, things that change over time or aggregations of both. And repositories is just a data access layer that seems domain-driven, so whatever pattern you can find, use it. The same goes for architectures. If you have messaging, CQRS, event sourcing, microservice architecture, or serverless coming up nowadays, all these things assist very well in doing better domain-driven design. But it is not domain-driven design. That's not what it's about. It's not about techniques. Techniques are just a tool you have to use to get better at building your domain core. So my own vision of DDD is like design what is, discover what is. You need to understand the problem that the company is in at the moment, and then you dream what can be. You come up with ideas, you have multiple ones, you can evaluate them and talk to each other about it, and then you design what shall be. You design the model, the code model, the architecture, the way the software should work, and that's a circle. It keeps going and going and going. Whenever you've implemented something, you are changing the system. The system pushes back, you get new insights, and you keep discovering. So how to model business software? Now comes the interesting part. I want you all to be really sharp. 3 steps, very easy. Whenever someone gives you something where they say 3 steps, super easy, if you do this, you get successful, don't believe a word they say. So 3 steps, super easy, barely an inconvenience. What we do here is we extract the right model to be able to help. Then we put the model into semantic code, and then we secure the code from corruption. And it's true because it's so abstract. So if you do these 3 steps, but not only in a row, even if I'm a German, this is a dance, not a march. You don't do step 1, step 2, step 3, software done. You iterate whatever happens when you learn something and you see, oh, my code doesn't fit, go put it into semantic code. If you see, oh, the model doesn't fit, go model more. Whatever needs to be done, do it. But this is the first order, the initial order. I do the steps in. Let's do it together. Let's extract the right model to be able to help. I brought 2 domain experts. And these domain experts brought their story. Please take a few seconds. So we already know what to do, right? What would we ask those people? Oh yeah, great. So, what's a dinglebob, what's a schleem, what are those terms? Great question, and the funny thing is, I can click and I get the nouns because I knew you would ask that, or anyone would ask that. That always happens, and it's the most unimportant question of all of them.
Oh, thanks, man.
You're welcome. So, it seems so obvious, we don't understand the words, so please explain them to us. This is garbage language. But any language is garbage language. You are not a domain expert. If people use words you might understand, you still get it wrong. This is just very explicit. You don't understand anything here. But if someone says Bundesurlaubsgesetz in German, wonderful, I have an idea, but I don't really know what they mean. So if I get my nouns defined, I still don't know what's happening in the domain. Even the definition contains words that need to be defined again. So, and this is an infinite loop if you want to. What's way better is look for those things. Domain experts give you a story and they say, oh, this is important because, fine, now someone said this is important. Let's challenge that notion. Why is it important? Oh, because the Fleep has all of the Fleep Jews. Well, that's not a reason. That seems like a reason, but it's not a reason. They just said because and then put in a sentence. What if I don't use Fleep juice? What if I use orange juice? That's a dumb question. And that's good, because dumb questions is what we are best at. We have no clue. So by challenging the model, I say this is important because you need the Fleep juice. Do you really? What if there would be no Fleep juice? And then the business people, you can see on their faces, sometimes they're like, makes no sense. Thank you, now I've learned something about your domain. But if I say, yeah, that would be really expensive, but possible, but no, we don't do that. Great, now I've learned something else. So I don't know initially what their reaction would be like. So I try to ask dumb questions. Everything that's important, I challenge. Is it really? But if you only say, is it really, is it really, is it really, you annoy them. So find smart questions, challenge the model. Next thing is the time frame. When they say first they take, then they do, then they take, just challenge the order of things. What if this happens before that? Well, first they repurpose, then they take. That makes no sense. Okay, great. I've learned something again. So what if you leave something out, if you switch the order, or if you do things in parallel? You just ask all those dumb questions and look at their reaction, and you learn while you do that more and more. You get more intuition about the domain. And then there are also things that don't seem like time. The flaps rub. It's put down there in the story, so maybe it's important in that order, maybe it's not. Just challenge that. What if we do that first? Okay, and then you have all these nice adjectives. You have like bunch, or later, or the regular old. Don't assume you understand. A regular old could just mean standard, right? But it could also be that there are regular youngs or irregular olds. You don't know that. My metric here, my heuristic is whenever someone gives you something that is binary, true or false, black or white, ask for the continuum. If someone says, oh yeah, that's a grayscale, right? Ask for another dimension. What about color values? If someone says, yeah, it's black, white, it's hue and colors, go for the next dimension, as long as you're creative enough to find one. Always challenge if there is not more to be discovered, and look what you can learn from there. But we still can't build software because there's a major question we didn't answer. What's the problem? You came to us with a story about your domain, and you told us what you want us to build maybe. But what is your problem? Are you trying to get into a new market? Is there a production problem? Can't you find more people? Is it like you don't understand it? I don't know what your problem is, so I need to find out. But the problem is, for us, that software development is a learning process, and learning is a bottleneck. Working software is only a side effect. What we actually do is we don't deliver software. Software costs a lot of money. It needs to be maintained and stuff. What we do is we deliver business solutions, and software is just a way of doing that. So we need to improve learning. How do we improve learning? Talking to each other. That's a great situation, right? This is a meeting I want to be in. Of course not. So we have a lot of problems here. First thing is, you have two parties opposing each other. Psychologically, you know, you're opposing me, and we're always like getting at each other. What you want is people standing shoulder to shoulder next to each other and attacking a model, not attacking each other. And sitting is very inactive. You know, I have a lot of energy. You've been sitting for an hour almost. So different levels of energy you get. The same happens in modeling at a meeting in your company. If people sit, they look at their phone, they Skype, they do whatever they want. They don't have to be aware. If people stand up and walk around, you can see who's checking out. It's a transparency tool. And the people next to me are my allies. I can whisper, what an idiot. He won't hear me. But the person behind my ally is opaque. I don't see that person at all. So we're not modeling together. So that's a big problem. You get your modeling partners depending on where you sit in the room. You don't want that. And everything that has been said vanishes. I've been in so many discussions where people are like, but you said, no, what I said was, no, but what you said. And then we're talking about what we were talking about 5 minutes ago. That's not helpful communication. So before words vanish, make them stick. Put them on sticky notes. That's where event storming comes in. Modeling technique by Alberto Brandolini. In event storming, you take the right people in a room, you take infinite modeling space, not a whiteboard or anything constrained. Just a paper roll that you put on a wall like that. Oh, beautiful wall, by the way. I want to do an event storming in here. So, and then you take sticky notes for everyone and pens for everyone, so everybody can start writing down stuff on sticky notes and put it on the wall. And in event storming, you start with things that happened in the business process. Terms in past tense. That's important, because if you give programmers sticky notes and say write down activities, they will write down method calls. Like they will give you commands, but that's not what you want. You want to understand what's happening in the business process. And in event storming, everybody in parallel is putting out their vision of the process. You can't make a mistake here. It's your vision. It cannot be wrong. It can be not helpful, but you'll figure it out together. So everybody is starting at the same time, 3, 2, 4, 5 business people, 5 developers, and all are like, this happens, and then this happens, and then this happens. Great. So you have a divergence phase, a lot of chaos in the beginning, that's normal. And then structures emerge, and then you converge to a model that you can actually use. You get an event stream that makes sense to both business people and programmers. And after a short while, you see this clustering of people, because that's where bounded contexts emerge. You see these people that care about shopping a lot, and these people that care about payment a lot, and a lot of people that care about the next context. So these are actual photos from an actual customer, and it's always nice to see this happening. And in the end, you get a big model full of events, and when you have the events, you look for where they come from. Why is this happening? Is it because a user has an intention and says, I want to buy stuff, so then you find your commands? If it's because something else happened, you find your automated business processes. If it is because time passed, you find your cron jobs. You get your software design just by talking about domain terms and not about architectural things. And that is what you want. You want to have a conversation with your business people about their business, not teaching them how to think in tables and objects. So, step 2, now we have our model. We talk to people, we model in words, and we get the whole flow of the domain, great, only in domain terms. And now we put that into an architecture. Like you see this model up here, every color has meaning. Orange is events, blue is commands, yellow is decisions. And then you take that and put that into an architecture like CQRS and event sourcing. Who knows CQRS and event sourcing? Cool, well, that's getting more and more each year. So, in CQRS, which just means command and query responsibility segregation, short term, of course, you build 2 different architectures. You build one model for the handling of your commands and your business behavior, and one model for the projection of information to screens or prints. So you can optimize each model for the task that it's made for. So if a user says, I see data, I see you have a car in your shop, and I want to have a car, I send the command, order car. Then the rule says, as long as car is in stock and customer is a trusted customer, the event happened, car has been bought. We can project that to any screen. So if car has been bought, we put it onto the shopping cart and onto the delivery and take it out of stock. Great. No, everybody who is looking at screens gets information from there. If someone else says, I want to buy car into the domain, also the domain is reprojecting its own state through the list of events. So if car has been bought, now there's one less car, maybe 0, so couldn't have been bought. And you can build your whole software in semantic terms if you use event sourcing, so getting the state of your domain from a list of things that happened instead of a table where you store your data. And that makes everything very semantic. And your domain becomes basically a black box that gets only events and commands, so messages in plain language. And your projections become a black box that only get events and queries and send out responses. And they become very easily testable and pluggable. And then you go into functional heaven after a while because objects just hurt and do a lot of work. So once you've built that, once you have very semantic code, you need to secure it from corruption. How do you secure your domain code from corruption? What you do is you build your domain on top. You don't build this hierarchical structure of I have a UI layer, a facade, a domain layer, and a database underneath. Your domain is pure. It doesn't know where it is or that it has dependencies. The domain doesn't load data from the database. There has to be a command handler that says, oh, someone wants to buy a car, so I know which domain object has to work for this. I load it from the database and I call the function. The domain object itself is pure. It doesn't have any dependencies. So the same technical object you can put in a test that gets tested purely in language is the same object you put into your domain, and it does not have any dependencies. Its state gets loaded elsewhere, its result gets stored elsewhere, and it's just doing domain rules. That's why it's so important to not have primitive data types. So every function call on a domain object is only a term in domain language, and every type is a domain type. So it's really obvious to see if you're doing it right. And then structure emerges pretty naturally. So what you do is you build this, it's called hexagonal architecture, but it's basically just ports and adapters. You build ports and adapters that do the translation. And these are the only parts in my code where I see English and German mixed. Because someone is sending me a REST call, I take that REST call, I understand what to do with it, and then I call the business function, give it the parameters, take the result, and send the result over the REST interface back. That is very abstract and a very short description for something that can be very complex, of course. But doing this is the technically most important part. Distinguishing between infrastructure and domain is crucial if you want to have good domain-driven code. But why zum Geier would you do that? It's a lot of effort, it takes a lot of money, and a lot of changing the behavior of the whole company. Well, you want to do it because software becomes what the developers understood, not what business people meant. So in the end, you want that to be the same thing. So if I read my domain code and I can read the story, I understand. If not, I can ask the business people, and we don't care about the technicalities at that moment. So we want code in harmony with the business and a high internal trust in our team. And the team is not developers, it's developers and business people of a certain bounded context. And we want to be safe from external influence. Just because the others are changing their database, I don't want to have to work. I only want to work when I change stuff. And then again, for the management perspective, we want to move away from reward and punishment and strive for engagement. I don't want to punish people for doing a mistake. I want them to embrace their mistakes and learn. So I want to give the teams autonomy. This is from David Pink's book, Drive, What Drives People. You can have autonomy in what you want to do and when and why and how. You can build mastery. You can build technical mastery. If you're very into using frameworks, learn CQRS and event sourcing. That's fine. Become a master in that. If you want to be master in business rules, understand your business, you can work in that. And even in facilitating, if you're not really good with technology or with business people, but you're good in facilitating and a good Scrum Master or something, you can master any skill and it's useful in a domain-driven design context. And purpose is kind of a given. If you use domain-driven design, it's all about purpose, nothing else. So we're kind of out of time, so I'm rushing the last 2 slides. If you want to read more, take a picture of that slide because I'm not going through all the books now. But as you can see, it's only 3 development books about DDD, and the rest is psychology and team psychology and system thinking. It's like if you build software, being able to use your tools is crucial, but that's a given. The really hard part is not code, the really hard part is people. Understanding people is crucial to building good systems. And domain-driven design changes everything once you start. It changes your code, your culture, the way you do agile, and your whole architecture. You don't have to do everything at once. You don't have to start with the whole shebang. Start with value objects and just increase the readability of your business code. Use use things you put into your constructors and refactor the dirty database part out of it. So start somewhere and then get better. And if you want to learn more, there are a few conferences around the world that you can visit. In end of January, there's DD Europe in Amsterdam, and October, Kandinsky in Berlin, of course. And now, goodbye. Go forth and have meaningful lives. Thank you very much.